Hey everybody, it's Mr. Uchimi here. Today I'll be going over the scientific method in regards to setting up experiments and getting you guys ready for the science fair. Now the purpose of the scientific method is to create a set of steps that are used to help explain and or investigate a natural world around us, or the natural world around us, a certain phenomenon. Now I don't want you guys getting caught up on the first step because it depends on who you talk to, it might vary. But generally, you either want to do an observation or state a question. With that being said, if you identify a problem or state a question, be sure that the question can be tested via experimentation. Just don't say or come up with an experiment that can't be tested. Next, once you come up with that question, it's in your best interest to research or make more observations about this specific question or problem that you've created. Once you've done that and you have the things going, come up with a hypothesis, create one, an if-then statement. If this happens, then that will happen. Next, what you want to do is you want to create the experiment. That means you'll list your procedures and come up with a material list in order to conduct the experiment. Next things next, or next things up. What you want to do is you want to create the actual experiment itself. You want to perform it. You want to be able to do this experiment. And then once you do this experiment, the next thing you want to do is to collect the data from the experiment. You want to collect it and you want to analyze it just to see if anything needs to be reworked in the experiment. If something does need to be reworked, you need to modify the experiment. Sort of like what we did in class with the bag of popcorn. A lot of you guys realized that the microwave wasn't plugged in, so you had to rework the steps of the procedures. Lastly, you want to create a conclusion. It's highly important that you know that you cannot prove a hypothesis. You may only support it with data, which is why it comes down to this last step, which is always the last step. You want to communicate your results. Once again, you can't prove your hypothesis, you can only support it with data, and here's where you show your data to the world. Next, let's talk about the independent and dependent variables of the experiment. This is what sets your experiment apart from each other. So the independent variable is the variable that can be manipulated. For example, Mr. Uchimi is testing the rate of growth in plants based on the amount of fertilizer used. What is the independent variable? I'll give you a second to figure this out, and then I'll give you the answer. The variable that's being manipulated, what is it? If you said the amount of fertilizer used, you're correct. The only thing that we're changing or modifying in this experiment is the amount of fertilizer used. Therefore, it's 2.5 grams and 5 grams. Now, the dependent variable is the part of the experiment that we are measuring based on the changes given in the independent variable. So, based on the same scenario, what's the dependent variable? Give you a couple more seconds. All right, here we go. Well, the dependent variable is the rate of growth. Now remember, the dependent variable is what we're measuring. We were measuring the rate of growth. Now I know this might be a little confusing to some. So when I'm confused about something, I like to practice. So what we're going to do is we're going to practice a couple scenarios. And I want you to say out loud before the answer comes up on the board. Now, if I were you, I would pause. Even though I do give a 10-second pause, I would recommend you pause in between each question. Let's do it. Alright, Mr. Uchimi wants to test the effectiveness of Rogaine on hair growth. What's the independent variable and what's the dependent variable? If you said the independent variable was the effectiveness of Rogaine and the dependent variable was the amount of hair growth, you're absolutely correct. Next example. John Cena wants to test which brand of tires takes the longest to stop a vehicle going 50 miles per hour. What's the independent variable? What's the dependent variable? Now keep in mind, what are we adjusting? Or what do we control in this experiment? That'll give you your independent variable. Now if you said the independent variable was the brand of tires and the dependent variable was the amount of time it takes to stop the vehicle, based on those tires, you're 100% correct. Next, SpongeBob SquarePants is the best Krusty Burger flipper in all of Bikini Bottom. Mr. Krabs wants to determine if SpongeBob's pay affects SpongeBob's productivity. What's the independent variable and what's the dependent variable? So, in a sense, What's the cause and what's the effect? The effect is what we're measuring. So what are we measuring here? That'll give you your dependent variable. And what's causing that? That'll give you your independent. Alright, if you said the independent variable was SpongeBob's pay and the dependent variable was his productivity, then you're 100% correct. Now that we have that out the way, let's go over control versus experimental group. The control group is the group that doesn't receive the independent variable. They're just there as a baseline or a measure. The experimental group is the group that does receive the independent variable. They're used in the experiment. Now the constants are the factors that stay the same throughout the experiment. These are highly important to keep everything equal to one another so we can actually have a correct or accurate measure of the actual experiment. Now you see the food dye here. And lastly, let's get some more practice including control and constant. Alright, researchers want to know the rate at which different age students were able to complete a Pokemon jigsaw puzzle. What's the independent variable, dependent variable, control group, and or constant? Now keep in mind, not all of these are present in this scenario. Alright, if you had the age of the students as the independent, the rate of completion as the dependent, you had no control group, and the constant being the jigsaw puzzle, you're correct. Remember, the jigsaw puzzle was done by all students regardless of age. Next example, Smithers thinks that a special juice will increase the productivity of workers. He creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of paper each group has made. Group A has made 1,587 stacks. Group B made 2,113 stacks. What's the independent, dependent, and what is the control group? If you had the independent variable as a special juice, the dependent variable, the amount of paper staples, and the control group as the group that did not receive the special juice, hence independent variable, then you're 100% correct. Now, if you still need questions or more practice problems, just go to my website, which is www.mruchimi.com. You can either click Contact Mr. Uchimi, or you can go to the notes section and go to Scientific Method, and this will help you out a lot. Thanks.